Alrighty nerds, as promised, I'm going to go ahead and try to bop through the rest of the skills in this review packet for you. I am going to skip around, just for the length of the video's sake. Remember that you can pause or anything like that, so I am going to move a little bit faster than I do when I'm in the classroom, just because, well, no one wants to watch an hour-long video, plus I don't have that long to record it because this is my planning period. So I got about 40 minutes. Let's see what we can make happen. Remember, you can hit me up on Thrill-Share Rooms as well. Well, if you had to email tonight when you're working through the stuff, be sure to check out the small YouTube videos that I linked in the paper that's on Schoology as well. And I will have an answer key to the second one as soon as humanly possible, I promise. Okay, I know that one of my classes got to it, but not the other two. Number 19, talking about multiplying these two expressions. And I know that in Algebra 1, you may have used the term FOIL. In all reality, there is no such thing as FOIL. What there is distribution. So we could take this 3x and we can distribute it to the 5x. And we could take the 3x and we could distribute it to the 3y. We could then take this y and distribute it to the 5x, and we could take this y and distribute it to the 3y. So what is FOIL? FOIL stands for first, outer, which would be like, so first, outer, inner, last. It's simply just an order of distribution that tries to put like terms in the middle. But anyway, it is just distribution. The 3x gets distributed, the y gets distributed, and we are going to have 4 multiplications. Every little curved line is a multiplication. 3x times 5x gives me 15x squared. 3x times 3y gets me positive 9xy. Y times 5x gives me 5xy. And y times 3y gets me 3y squared. Like terms right there. They're like terms because they have the same variable with the same exponent. So I have 9 of them and 5 more of them, giving me 14 of them. And this question is finished. Try to keep your variables in alphabetic order. That's why x squared comes first, and then there's an xy, and then the y squareds. Somebody asked me, could this go anywhere else? And I said, not with the xy. If it didn't have an x, though, it would be written after the y squared. But because of alphabetic order, x's are going to come before y's. There's nothing different with this one, except for your like terms are going to be kind of all over the place. So challenge yourself with that one and check the answer key. These two questions are going to be all about factoring numbers, but in a very specific way. You need to know your perfect squares if you're going to simplify a square root by hand. What is a perfect square? A perfect square is any number that can be found by multiplying something to itself. For example, 4 is a perfect square because 2 times 2. 9 is a perfect square because 3 times 3. 16 is a perfect square, 4 times 4, 25 is 5 times 5, 36 is 6 times 6, 49 is 7 times 7, so on and so forth. And you need to know your perfect squares. It's going to make big things like 288 much easier to deal with. If you're in the habit of breaking these things down into number trees, because that might be the way your teacher showed you. If you did it like this, 288 is 2 times 144. And then 144 is 2 times 72. And then 72 is 2 times 36, 2 times 18, 2 times 9, 3 times 3. And then you started looking for pairs of stuff like, there's a pair, and there's a pair, and there's a pair. Like, that's too much work. Look at all of that work. Instead, I would rather know that 144 is a perfect square. This number is 12 times 12. So I recognize that 288 is not a perfect square. So the first thing I would do is ask myself, well, what big perfect square could I divide this by? And it helps if you have them memorized. So like I said, it is 144 times 2. 2 is not a perfect square, so it is going to be stuck inside the radical. I'm in the habit of teaching my students to circle the thing that's stuck. Now 144 is a perfect square. I could take the square root of 144, which is 12. However, the 2 is stuck inside. Because because this one's really, really easy to do, 100 is a perfect square. This is 100 times 5. Split it that way. A minute ago I talked about like terms. Boop, right here in purple. You see, these two things are not like terms the way they sit. In order for radical expressions to be like terms, you must have the same radical. And these don't. This says root 8 and this says root 18. So will you just like, call it a day, I'm done, there's nothing I can do? No. This radical simplifies. This radical simplifies. So let's talk about this root 8 first. What perfect square can I divide 8 by? The answer is 4. 4 goes into 8 twice. And what perfect square can I divide 18 by? The answer is 9. 9 goes into it twice. This will be stuck. This will be stuck. Oh, look at that. They're both going to have a 2 under the radical. So when I'm finished simplifying, they will be like terms. See how this is multiplication in here? And believe it or not, this is actually multiplication right here as well. When this 4 comes out, like, this 144 came out as a 12. When this 4 comes out, it's going to come out as a multiplier. Its square root will come out as a multiplier. And when this 9 comes out, its square root will come out as a multiplier. So it's actually going to be 8 times the square root of this 4. Oh, and there's still a 2 in there. Minus 2 times the square root of this 9. Oh, and there's still going to be a 2 in there. That is 16 root 2's minus 6 root 2's. And 16 cookies minus 6 cookies is 10. Whoa! I already knew what the answer was, so I was writing it. Stupid. So what happens when you're in a rush. There it is. They're like terms. You can subtract them. This one's going to work the same way. 25 goes into 75. Go from there. Next. Oh, look, one of my absolute favorite F words, factoring. Factoring a quadratic means break it apart into the 2 sets of parentheses that were multiplied together to give you that quadratic. So imagine this didn't have any y's in it. This thing would look a lot like this thing. And it can be factored into 2 sets of parentheses that multiply to give you that quadratic. Are you super good at factoring right now? Probably not. Yes, you learned it in Algebra 1. I know it's been a long time, and we will cover it more in class in a later chapter, but I do still need to know if you at least understand what it is. So, these two are the easy kind. And by the easy kind, I mean there's no number in front of x squared. Because when you have a number in front of x squared, it does make the question slightly more difficult. For these, there is a shortcut that you can use, and it works like this. What 2 numbers multiply to give you the number at the end that add to give you the number in the middle? Okay, so let's do this one. Looking for 2 numbers that will multiply to negative 48 that will add to 13. The only way that, I got to pause the video because I have a guest. Okay, back to it. Anyway, the only way to multiply 2 numbers to get a negative is if one is positive and one is negative. Now, so I have a positive number and a negative number that I have to multiply to get negative 48, and those 2 numbers need to add to be a positive 13. The only way that a positive and negative add to be a positive is if the positive is the larger number. And I mean in magnitude. I just mean like the bigger number, okay? Not the one with the larger value. All right, so numbers that multiply to 48. 1 and 48, not going to add to 13 with positive 48 and negative 1. 2 and 24, no, negative 2 and positive 22 adds to 20. 3 and 16, 3 would be negative. Negative 3 and positive 16, bingo, there it is. Negative 3 and positive 16 add to this number, and it's going to be multiplied to this number, and they add to that number. This is a shortcut method because once those 2 numbers have been identified, you put an x in the front of both of these, because remember when you do your whole FOIL thing, the first thing you would do is x times x get x squared. The 2 numbers that multiply to that, which would be the L part of FOIL, this is the I part of, well, the outer and the inner part of FOIL, adds together to give you that. Those 2 numbers were negative 3 and positive 16. There it is, it's finished. This could have said x plus 16, this could have said x minus 3, order doesn't matter. Now here, 2 numbers that multiply to a 15 and add to a negative 8. Well, the only way to multiply to a positive number and add to a negative is if you're multiplying two negatives. So look for two negatives that multiply to 15 that add to -8 and make it happen. Now these two are going to be a slightly extended version of this. The very first thing we're going to do is take this 6 right here, and we're going to divide, boop, 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 all three of these things by 6. No, we're not. Hold up. Wait a second. I missed a step. First, we're going to multiply the 6 and the 10 and get to 60. So 6 times 10 is 60. You know what? We're not even going to do this division thing. That's a method that I'm not going to show you right now. We'll hold on to that to a later point in time. For right now, 6 times 10, negative 10 is negative 60. So you're imagining that it says this. It doesn't, but you're pretending it says this. We took the 6 and we multiplied it to the negative 10, and we're thinking about it like this. Now, we're going to try to get to here from this. What two numbers multiply to negative 60 that add to negative 11? Well, you can pause the video and think about it if you want to, but those two numbers are going to be negative 15 and positive 4. So I would write it like this. Now you put an X in the front of them, right? I said negative 15 and positive 4, right? Here's the problem. If you multiply these two black things together, you don't get this. You get this. But how did I get to here? Oh, that's right. I took the 6 and I multiplied it to this 10. So to cancel out that whole multiplying the 6 to this 10, I'm going to divide by the 6. We'll do the division there. Both of these fractions reduce. We have to reduce our fractions. Now we have this. Let's see, I can divide both those by 3. I can divide both those by 2. The last step of this method says, after you're done simplifying, or reducing, excuse me, the number that sits on the bottom of the fraction scoots in front of the x. If there's not a number on the bottom of the fraction, don't worry about it. What we're left with is 2x minus 5 times 3x plus 2. These two would multiply to give you that. Try to do it here. 5 times 14 is 70. Okay? Hunt for the two numbers that will multiply to positive 70 and add to negative 17. And just be sure that once you find those two numbers that you divide by the a value. Remember when I showed you the ax squared plus bx plus c? You're dividing by the a value if there was one, because that's how you got to here. All right. Moving on. Solutions to absolute value equations. Well, what is an absolute value? First and foremost, absolute value means how far away is something from the number 0. That's what absolute value means. This is an absolute value equation. And we're saying that we need it to be 9 away from 0. So this stuff is 9 away from 0. Well, the last time I checked, there are two numbers that are 9 away from 0. Positive 9 to the right of 0 and negative 9 to the left of 0. So we're actually going to write this as two different questions. We have 2x plus 1 was allowed to be 9 because 9 is 9 away from 0. And you also have, and you know, we'll call this the positive case. We also have the negative case. You see, because what absolute values do is actually they hide negative numbers from you. If 2x plus 1 was a positive number, meaning if we knew what x was, and if 2x plus 1 is a positive number, then the absolute value bars do nothing. But what if 2x plus 1 was a negative number? The absolute value bars would have hidden it from us. So what I'm going to do is, for the negative case, I'm going to say, what if all of this was multiplied by negative 1? I know that this is probably not the method that your Algebra 1 teacher showed you, but I'm telling you, it's a better method. Okay? Let's handle the positive case first. Subtract a 1 from both sides. Boop, boop. Gets you 2x equals 8. Divide both sides by 2. X equals 4. Okay, cool. Here. Distribute the negative 1. Add 1 to both sides. Divide both sides by negative 2. And here we have two solutions. Ta-da! This question is a trick question. Why is it a trick question? Every number that comes out of absolute value bars has the exact same thing in common. Every number that comes out of absolute value bars is positive. So this says some positive number equals negative 12. Not possible. This question isn't possible because whatever comes out of here will never be negative 12. Watch out for that, please. Solving a quadratic equation. Solving a quadratic equation involves factoring, and since it says equals 0, you set the pieces equal to 0. Or you could use the quadratic formula in case it doesn't factor. Now, I'm a big fan of factoring, and I'm going to go ahead and tell you that the one on the test does factor. So I am not going to show the quadratic formula. I instead am going to show factoring. Alrighty. What two numbers multiply to 15 and add to negative 8? I hope you already figured those two numbers out right here. But the two numbers that multiply to 15, positive, and add to negative 8 are negative 3 and negative 5. And since there's no number in front of x squared, I can use a shortcut method. There's negative 3, and there's negative 5, and it still equals 0. Here's what this says. Something times something else equals 0. Well, look, the only way that two things are going to multiply to give you 0 is if one or both of the things equals 0. That means that x minus 3 could be 0, or x minus 5 could be 0. Add 3 to both sides to give you x equals 3. Add 5 to both sides to give you x equals 5. These are known as the solutions to the quadratic. I'll leave you this one, but remember, just like this one and that one, the first thing you're going to do is say, well, what if this 2 was multiplied to this 15? Instead, I was treating it as a w squared plus 13w plus 30 equals 0. Don't forget to divide by a right here and go for it. You should have at least one fractional answer, maybe two. Okay. 33 and 34. Notice that you don't have x's and x squareds like we had in this one. When you have x's and x squareds, you had to bring everything to one side and try to solve by factoring a quadratic formula, something like that. But when you don't, when you just have x squared, you could solve by factoring, or you could do something that I think is a little bit easier, and we just call it solving by square roots. Get x alone. Do some sad map. You know, solve for x. Let's do this one. Let's do sad map. The first thing I would need to get rid of is the minus 4. So add 4 to both sides. What's a good color? I'm already holding green. Divide both sides by 9. Fractions. Eek! Don't be scared. It's no big deal. X squared equals 4 over 9. There. Now all you have to do is remember how we cancel squares. We cancel squares with square roots. Oh my goodness, really? Now that the announcement is over. Anyway, I was in the middle of taking the square root of both sides. On the left side, I have canceled a square with a square root. Anytime you cancel a square with a square root, it creates a plus or a minus. Why? Because if you take a negative number and you square it, you're going to get a positive result. So what we're doing is we're saying something was squared and a positive number was my result. So all you know then is that squaring got you the positive. You don't know if the number that was being squared was positive or negative, because either way, positive would have been the result. So when you cancel a square with a square root, specifically in this order, it creates this plus or minus. Now we're just going to take the square root of stuff. Hey, we've already talked about that. Good news, everybody. 4 is a perfect square, and 9 is a perfect square. Square root of 4, the two numbers that multiply together to give you 4 are 2 and 2. 9 is a perfect square. The two numbers that multiply together to give you 9 are 3 and 3. Those are your solutions. Another reason why you could think about it as having two solutions is because it factors really nicely. Not that we're not going to review the factoring on it, but this thing actually factors to this. 3x plus 2 times 3x minus 2. And since it equals 0, if you solved like I did here, you would get two solutions. They would both say 2/3. One would give you a positive 2/3. The other would give you a negative 2/3. Okay? Okay. Now, come on down to 35, 36. Oh, old buddy PEMDAS has come out to play. Both of these things require you to follow the order of operations, and that is literally all you need to do for these two questions. So I'll probably just do 36 for you. Someone just opened my door and then closed it. I don't know who that was or what was going on, but they pieced off real fast. Anyway, parentheses. That means go inside the parentheses and see what you can do. -2 plus 6 is 4. Exponents. Okay, 4 squared, that's 16. Multiplication and or division. Did you know the order doesn't matter? It doesn't matter, multiplication or division. And when you have both, you might as well just do them from left to right. You might as well do them from left to right. Here's the thing. This is not 4 divided by 2. It's -4 divided by 2. The symbol that sits in front of a number is part of that number. -4 divided by 2 is -2. Now the multiplication. Again, the symbol that sits in front of a number is part of that number. So this is -16. This is -6. And -16 minus 6 is -22. And questions like this are why you can't use a calculator on the prerequisite exam, because your calculator, if you have the good one, the one that's solar powered, would do this for you. And I need to make sure that you have those abilities. Flip them. Evaluate. What does that mean? It means plug it in. That's it. Just plug it in. No big deal, okay? I'll do this one. I'll leave the challenging one for you. Plug it in, plug it in. Just make sure, please, that when you are substituting, you're using parentheses. So I have A, which was 2, times B, which was -4, minus my B value squared. Remember, that minus sign does not have an exponent, just the B does, and that's why I've used parentheses. I throw the -4 here, and there's plus 20. 2 times -4 is -8. Minus -4 quantity squared means -4 times -4, which is positive 16. -8 and -16 is -24. And if you owe someone 24 bucks and you pay them back 20, you still owe them $4. And see how I did it in green, talking about money? There it is. All right. 39 and 40, same kind of question. Solving for an unknown variable. This is a multi-step equation with variables on both sides of the equation. Why is this on here? Because of this bad boy right here. You have to do distribution, but you are not distributing a 3. This question is on my test to look for students that don't know, that you have to distribute a -3. The symbol in front of a number belongs to that number. They cannot be separated. So you must distribute the negative with the 3. It gives me 14 plus 3n equals 8n. Now -3 times n is -3n, and -3 times -4 is positive 12. These are like terms. I don't want to have to mess with negatives if I don't have to, so I'm actually going to move my variables to the right. I'll move my non-variables to the left. And let's see, 14 minus 12 is 2, and 5n minus 3n is 2n. Oh, if you divide both sides by 2, you get n is 1. And there you go. Same thing happens here. Look, there's a negative. He put it on both examples on the review. I wonder if it's going to be on the test like that. Eek, fractions, right? I know, they are so frightening. So frightening, I know. Not. Anyway, here we go. Trying to get this x alone, right? Got to do sad mep once again. Sad mep. So the first thing I'm going to do is get rid of the addition subtraction. Goodbye, minus 2. Let me just add this 2 to both sides. I now have 16 divided by x equals 48. Don't fall into the trap. You cannot divide both sides by 16 here. Why, Mr. M? Because x is on the bottom of the fraction. This literally says divided by x. If the thing you're trying to solve for is in the bottom of a fraction, your job is to get it out of the bottom of the fraction. We need to cancel this divide by. Well, how do you cancel divide by x? Simple. Multiply by x. Just do it on both sides. You see, on the left, times x divided by x cancel out. And you're left with 16 equals 48x. And you just divide both sides by 48. And then reduce your fraction. And keep reducing and keep reducing. And eventually you will get that this reduces down to 1/3. Maybe you divided this by 2 and by 2 and by 2 and by 2 and by 2. But you just did it a bunch of times. Or maybe you did by 4 by 4 by 4 by 4. Or maybe you know that 48 is 16 times 3. Either way, keep reducing until you get all the way down to 1/3. This one does not have x in the denominator. So please don't just memorize how I did this. Know why I did it the way I did when you solve this one. Okay? Okay. You saw me do one like this already. Distribute and then go from there, okay? I'm telling you f of x is this quadratic. Actually, you know what? Let's do this one because it looks more fun. And by fun, I mean scary. Let me do this one. I'm telling you f of x is this, technically not quadratic. This is just some random thing I threw together. What does f of -4 mean? When I say find it, what does that mean? You can't ask me on the test, what does that mean? I'm going to tell you that's what the test question is. Do you know what that means? So no, I can't tell you. Well, how about this? Here's your hint. Do you see how x got replaced with a -4? It's because that's what you're supposed to do in here. Replace x with a -4. Let me do it in color so that you can see it happening. Every time I substitute, I'm going to use parentheses, unless they're ridiculously not necessary, like down here. Okay. Red and blue together make purple. -4 quantity squared means -4 times -4, which is 16. 8 divided by -4 is -2, and there's still a -1 here. 16 minus 2 is 14, minus 1 is 13. Done. This has literally replaced x with -4. Okay. And I know that was really, really fast. I'm sorry, but we got to do what we got to do. Formulas that you must have memorized. The slope formula. Okay, we did that in the notes. y2 minus y1 over x2 minus x1. Point slope form, or excuse me, slope intercept formula, y equals mx plus b. You know, you don't have to have point slope formula memorized. Don't worry about it. The quadratic formula, if you can't factor, make sure you know the quadratic formula. If you can't factor, x equals -b plus or minus root b squared minus 4ac all over 2a. Know the axis of symmetry for a quadratic. X equals -b over 2a. Don't forget to watch out for doubles and triple negatives. Distance and midpoint. I don't even think there was any distance stuff in the review, so that must not be on the test. You know what? Don't even worry about it. Midpoint formula. We did that. It's literally average the x's, average of the y's. So easy. And Pythagorean theorem, I just throw that in there because you should know that a squared plus b squared equals c squared. Because you never know when I'm going to throw some extra credit on there that I didn't put in the review. Anyway, if you have questions, please hit me up through Thrill Share. Look at the answer key that's on Schoology, watch some of the short videos that I've put in that document, and I guess watch this video and pause this video, and be prepared to ask me tons of questions in class tomorrow. Okay, thank you so much for getting through this with me, nerds. I appreciate all of the effort.